Today we are going to talk about what's new on Cloud Composer, which is our GCP's managed Airflow offering. And my name is Piotr Wieczorek. I'm a lead senior product manager in Cloud Composer. And I will have a pleasure today to co-present with my colleague, Michał Modras, who is Cloud Composer lead engineering manager. So with that, let's start with our Cloud Composer's vision that we are following since the beginning of Cloud Composer. So our vision is to let Google handle the infrastructure so that you can focus on your DAX only. And with that, we have fairly recently launched our latest and greatest version of Cloud Composer. It is Cloud Composer 3. It was launched to GA in December 16th, so it's over 9 months ago. And since then, we have already a number of enterprise customers using our latest and greatest version, which has already proven its reliability and robustness. And as you can see on the slide, since the launch of Cloud Composer 3 to GA, we've introduced a number of features, and we keep working on delivering the new features. The list is not exhaustive, and also we will deep dive on subsequent slides into some of those items. But just to name a few, the features that we have implemented are scheduled snapshots, which allows you to create the snapshots of your environment on a regular basis. And there is a number of use cases that we'll talk about in which the scheduled snapshots are super useful. We have also implemented the database retention features, which basically automatically purges your Airflow metadata database, making sure that it is kept within size to ensure that the environment remains performant. We have also introduced the local development capabilities, which allows you to create a local runner of Cloud Composer on your local machine. And thanks to that, you can very quickly make the development iterations and create your DAG code and then run your DAG code in your local environment before uploading that to the cloud. Then we have also implemented a high availability mode to Cloud Composer 3, which basically allows you to create Cloud Composer environments that are immune to zonal failure, essentially making Cloud Composer environments a regional resource. And let's move to the next slide and also briefly highlight the most important changes that we have introduced to Cloud Composer 3 versus our previous iteration, Cloud Composer 2, which might be very familiar to a number of you. The first one, based on the feedback that we got, we have significantly simplified the networking setup in Cloud Composer. So in our latest version, there is only 0 or maximum of 2 IP addresses that are needed from your IP range, which is an order of magnitude improvement versus our previous iteration, which needed up to even 2,000 addresses, and also the overall networking setup is significantly simplified. We have also hidden the cluster and virtual machines, and all of the components are now within Google project, so that you don't need to worry about them anymore. And it also mitigates the risks of, first of all, accidental deletions of those components, but also it mitigates the risk of conflicts with your enterprise infrastructure policies. We have also significantly improved DAG runs reliability. We'll talk about that more in the subsequent slide, but now scheduler and DAG processor are isolated, which brings a lot of benefits, including reliability improvements. We have also significantly minimized the impact of maintenance operations to your environment. In Cloud Composer 2, the impact was possible when the task was running for more than an hour. In Composer 3, it is guaranteed that task running less than 24 hours will not be interrupted. We have also improved or increased the storage per worker, and we have also added a new Celery Kubernetes executor that brings a lot of new options and capabilities to Cloud Composer, but we'll talk about that later. Also, just to highlight, Cloud Composer 3 supports both Airflow 2 and Airflow 3. As of now, Airflow 3 is available for selected customers under private preview. So let me move on and deep dive into some of those elements that I have just mentioned. So the first one is an overview of how our architecture evolved between the subsequent versions of Cloud Composer. As you can see in Cloud Composer, it's only a storage bucket and Cloud Composer environment itself that are in customer project. Everything else is now hidden in a Google project, and it is for us to make sure that everything works properly. I already mentioned the benefits that it brings a minute ago. Now about networking, to give you also a brief overview as to what decisions you need to make now with Cloud Composer 3. So the key decisions are whether your networking type is public or private, and this is the difference between the top and the bottom. And then whether you want your Cloud Composer environment to be connected to your VPC network. And this is the difference between left and right. The most common one is the bottom right one, where networking type is private, so that it's not exposed to outside world. And at the same time, it is connected to your VPC network. One additional optional decision that you can make is whether your environment will have exposure and connection to PyPI.org. And then one item to add to it, that even though your networking type is private and your VPC network is enabled, the environment still can have access to internet. And the way it's usually configured by customers is that all of the internet traffic for security reasons are routed through your VPC network based on your VPC configuration, firewall rules, and so on. Now, I've mentioned earlier that the DAG parser and scheduler were separated, and that actually is super helpful in making sure that one doesn't overtake the resources of the other. And what sometimes used to happen is, especially for huge environments with like thousands of DAGs, there were occasions where DAG processor was so busy parsing DAG that it was overtaking all of the resources, and as a result, the scheduler didn't work properly, or sometimes occasionally it failed. Now in Cloud Composer 3, it's not going to happen anymore, given that those two components have now separate resources that you would obviously see, and you would be able to tweak them as well when you create your environments. And with that, it significantly improves the overall performance of your environments as well as reliability. With that, I will stop here and I will hand over to Michał to continue on the deep dives that we have on subsequent slides. Michał, over to you.
So one of the features we introduced in Cloud Composer 3 is Celery Kubernetes Executor. So you might know in Composer 2, we used Celery Executor purely, which means Airflow tasks are distributed to the Airflow workers. Each Airflow worker runs a number of Celery workers that you can configure. And this setup is very effective when you require low latency and when the tasks that you execute are lightweight. But if you're more concerned about any noisy neighbor effects from tasks running on the same worker, or if you have some special needs for your task, like for example, you want to have dedicated resources set up, you can now use Kubernetes Executor, which means that for each task, there is going to be a dedicated Kubernetes pod scheduled in the cluster hosting your Airflow deployment in Cloud Composer. And this pod will be resourced as you'd like. It will be also separated from any other task running on the cluster, so the noisy neighbor effects in Celery are not here. This is an additional advantage over using Kubernetes Pod Operator, because with Kubernetes Pod Operator, you can basically use only the image of your choice, and then you had to implement whatever you liked, while in Kubernetes Executor, you can benefit from all the Airflow operators you have. You can just pass the parameter of Q Kubernetes, and no matter what operator you want to execute, it will be executed using this operator. So as mentioned, this new executor is only available in Composer 3. One interesting feature is that you can actually mix them within a single DAG. So if in a complex DAG you have some simple tasks to be executed, or some tasks to be executed that require low latency, you might want to run them using Celery, and in the same DAG you can actually have some heavy tasks that you would delegate to Kubernetes directly. So as with Composer 3, we introduced this Kubernetes executor, and at the same time, we also abstract away more of the infrastructure and manage it for you. We introduced additional observability layer to provide insights about these Kubernetes workloads and in general Airflow workloads running in your cluster. So there is additional pane of observability, providing information about the components, their metrics, utilization, logs, and so forth. As you can see, in the user workloads section, you will see all the Kubernetes pods that have been scheduled by your components, and you can just view their details straight away. If we go to the next slide, you will see, for example, graphs for CPU and memory. So the difference with Composer 2 is mainly that now you don't need to go back and forth between the Kubernetes cluster and your Composer instance, but instead you have everything in one place, making any debugging and work with these components more efficient. Another feature we introduced is database retention. So you might know the Airflow database cleanup DAG. That's an open source DAG that removes some old entries from your database, such as old metadata from task runs, old XCOM communication between tasks, old logs stored in the Airflow DB, or other old metadata. In order to keep your Airflow database small and healthy, and therefore more performant, it's recommended to trim this old metadata, and there is this open source DAG that anyone can take and run in their environments. But to make things easier and smoother, we actually can manage that for you in Cloud Composer. So we introduced the database retention feature built into the Airflow deployments, so that you can automatically configure your retention period. Say you want only to keep data from the last 30 or 60 or how many days. And then we'll assure that in regular maintenance, your database will be trimmed to only that time period, and the older entries will be removed, making for a smaller and more efficient database. This will also this is also an enabler for using snapshots in a more advanced way, because snapshot functionality, which basically takes a snapshot of your Airflow deployment of your Composer environment and then enables you to bring it back, also includes taking a snapshot of the Airflow database. So if your Airflow database grows under control, then that can become problematic for using this functionality in some short time that you would like to have to, for example, restore your environment in case of an outage. So snapshots, especially when used with environments with small databases that have proper database retention configured, are a good tool to plan for disaster recovery. Snapshots can be executed on demand through save and load operations, but you can also define the schedule for them to be automatically executed. And if you do so, then, for example, every hour or every 12 hours, or depending on what your business goals are, this functionality can take a snapshot of your environment, which will be ready whenever an outage happens, and you can load it to your backup environment, or maybe you want to recreate your environment and load it there. This functionality can be used also with in many other contexts. It's a very good migration or upgrade tool, so you can actually use this to save snapshots of your environments in older Airflow or Composer versions and load the snapshot in a newer environment. So this gives you a chance to try out and test the new version on your own first, and only then load the old configuration to move, for example, your production workloads. Another functionality we've introduced recently is custom organizational policies. So this a feature enables you to define some conditions you want your cloud resources, in this context, the Composer environments, to meet. So, for example, if you care a lot about resilience, you might want to configure that all your environments need to have certain number of replicas of certain components, like, okay, no fewer than 2 schedulers. Or maybe if you care about security, you might want to say that all my Airflow deployments need to have at least this version and not older, because the older versions have some security vulnerabilities, and so on and so forth. So this is fully customizable in line with the parameters that are available in the Composer API, which are basically the Airflow configuration parameters for your deployment. And then one more functionality we brought is integration with BigQuery. We know that BigQuery is a super popular service used with Airflow and Composer. There is a number of BigQuery operators in the Google Provider Package. So what we worked on recently is introducing a scheduling page in BigQuery that will, in one place, show you your scheduled workflows that can be Airflow docs coming from Composer, but it can also be other objects, other scheduled objects like scheduled queries, or maybe data form queries, scheduled notebooks, etc. So all your orchestration objects are here in one place and can be managed from a single pane of glass. Last but not least, Composer is very proud of our security enterprise-grade posture. We have a number of certification, such as FedRAMP, HIPAA, and the long list here. For the up-to-date information and the full list, please refer to the public Google documentation. So if your business case mandates certain compliance certification, please check it out. Also, it comes with very advanced networking and data security toolset. For example, VPC VPCSC, so VPC service controls, and enabling which kind of services you want your environment to be allowed to communicate. Private environments described before, integration with Cloud IAM. Everything that you put in Airflow environments in Composer is encrypted at rest, in transit, with with the up-to-date state-of-the-art technologies. Equally, we also support a lot of functionalities related to managing and securely managing and auditably managing your Airflow deployments in Google Cloud. So we'll get any sort of notifications and audit logs for the defined set of events, such as if for support reasons we need to perform some sort of maintenance operation on your environment or such. There are tools for transparently making that visible and controlling it. Similarly, I've mentioned the encryption technologies in the previous section. We also enable customer managed encryption keys, so you can actually define the key you want your data to be encrypted. It doesn't need to be a key made up by us.